Hi there, this is Mr. Frew, and I'm making a video to help explain the idea of algebraic expressions to any 6th or 7th grade students out there that may need that extra help with these kinds of problems. So first, what is an algebraic expression? Well, let me express this idea with an example here. I have in my pocket my wallet here. Do you know how much money is in my wallet? Well, you can make a guess, and if you know that I'm a teacher, then you know it's probably not a whole lot of money, but the idea is that it's unknown. You don't really know how much money I have in my wallet. It could be a little bit, could be a lot. So for now, let's go ahead and let's just create a variable, a letter that's going to stand in place of whatever that amount is. So we could say M for money, W for wallets, A for amount. It could be whatever it is that's going to make sense to you. Let's go ahead and just use a number. Let's just go ahead and say M for money. So M is going to represent how much money I have in my wallet here. And if I want to express an idea, let's say you give me $5 more than I have in my wallet. So the money I have, we're going to add 5 more. Well, this is an expression. What we mean by an expression is basically a number sentence. Now, the reason why I have the variable, the amounts that we don't know in red, is because this is what makes this an algebraic expression. If I gave you the number, then you can go ahead and solve it. But because you don't know that amount until I tell you, then you need to go ahead and leave it as this expression. This is also something different from an equation, right? An equation would be if I included an equal sign. If I told you that the amount of money I have in my wallet plus 5 more is the same as 20, well, that's a slightly different kind of problem, and it's a slightly different claim that's being made. But for the purpose of this video, we're not going to look at equations. We're just going to look at expressions. So how can you solve this? Well, you can't. There's nothing yet known about how much money I have until I actually take out my wallet and show you. And in fact, I have 2 5s here and 5 1s. 1, 2, 3, 4, 5. So altogether, I actually have $15 in this wallet. So now that I'm telling you how much money is in there, you're going to be able to solve this when you are given that amount. So off to the side, I'm going to say M, that amount of money is equal to 15. Okay, so what does this mean in terms of what we're going to be doing? Well, all we're doing for this particular skill is replacing the variable M with what we know it to be. And they're going to give you, and by they I mean the textbook, the teacher, the test, whatever it is that you were studying for, should give you the amount for at least one of the variables to finish the problem. So where I see M, I'm just going to switch it out with the number 15 because we know how much money is in the wallet now. And I'm going to write out the rest of the problem so you can see what the steps are going to be. So we're just going to be adding the money I have plus $5 more. And you can go ahead and simplify this. And so the answer will be 20. So the expression is just a number sentence that relates to something in real life. So in this case, some amount of money plus $5 more. Now that you know the amounts, we can go ahead and simplify, evaluate, or solve. So these are different types of language or vocabulary you may see in a textbook or on a test, which basically just means simplify or solve this problem. So let's take a look at a more complex, but still a real-world example that we can use. So here's a real-world example that you may come across in science, and that involves Celsius and Fahrenheit. These are 2 different ways that temperatures, whether they're of liquids or of the air temperature, can be measured, but they're very different scales. Celsius is based off of when water freezes and boils. You may know Celsius to mean that water freezes at 0 degrees Celsius. and it boils at 100 degrees Celsius. But Fahrenheit's very different. And the United States will use Fahrenheit to express temperatures, and water will freeze at 32 degrees Fahrenheit, and 212 degrees Fahrenheit it will boil. So let's go ahead and look at this expression here. Right now I've written it as an equation. I have Celsius, but maybe you can think of this as C for Celsius. So C equals Fahrenheit, F, minus 32. And then we're going to first figure that amount, and then we'll multiply it by 5/9 using order of operations. So let's actually see the relationship between Celsius and Fahrenheit and plug in some values here. And again, because we're not really working with equations in this video, I'm going to go ahead and erase the C. But just know that what the purpose of this expression is to help us convert or change between Fahrenheit and Celsius. So I'm going to go ahead and plug in an amount for Fahrenheit, for F. So if you know that Fahrenheit at 32 means that water is freezing at 32 degrees Fahrenheit, well, if we plug in this amount, the whole expression should be equal to 0, because this is going to help us change it to Celsius. So let's plug that in and see what happens. Well, I'm going to use red for the number here. So I'm going to replace F with 32, because that's the amount that we know. So we're going to plug that in. And everything else, I'm going to keep the same. I'm going to copy everything over. I don't want to skip steps in my head. That's how easy mistakes are made. So we'll take it step by step. So before we can multiply, we need to handle the parentheses. Before we do anything, we need to simplify what's going on here. And we have 32 minus 32. Not too bad, because, well, we're taking away the same amount that we have. So we're going to end up at 0 again. So this is just going to be nothing, 0. Okay, well, that part was pretty easy. Now we're going to multiply 0 by 5/9. And it may look a little complicated with the fraction, but because we're multiplying by 0, it's a lot easier. Anything times 0 is going to be 0. It's going to be nothing. So it doesn't matter how complicated this number might be. If we're multiplying it by 0, the answer is going to be 0. That makes sense, because we just said that water freezes at 32 degrees Fahrenheit, which is the same as 0 degrees Celsius. And we were able to use this expression to show that. Now, let's try it with another example. Let's try it with boiling temperatures. So in this case, we're not going to use 32. Now we're going to use a different amount. So I'm going to go ahead and erase all this, and feel free to pause the video, and that way you can try this on your own, or you can rewind to get some more practice or explanation. So let me erase this. And this time, instead of freezing, let's use boiling. So we'll know that Fahrenheit at 212 means the water is now going to be boiling or evaporating. And if we plug in 212 for F, and we follow the same steps to simplify and evaluate this expression, the answer should be 100, because that's when Celsius, or when Celsius is at 100, that means that water is boiling. That's why they chose so simple numbers, 0 to 100. It's based off of water. So let's plug this in and see how it works. So again, I'm going to use red to show what I'm plugging in. So 212, and we're going to subtract 32. I'm keeping in parentheses so I remember what my steps are. We're going to do that first, and then we're going to multiply by 5/9. I still copy everything over, and that way I don't make mistakes, leave out numbers, things like this. So let's subtract here first. Well, I'll do some mental math here just to kind of share some strategies with you. If I am subtracting 32, I can actually break this up and think about it in two different ways. I can think of 212 and then subtract 12. Well, if I take away 12 from 212, I'm left with just 200. But I have 20 more to take away altogether. So I'm going to be taking away another 20 here. So that's just some mental math here. You can still set it up on the side if you want to do 212 minus 32. But the answer will be 180. And you can go ahead and traditionally line it up. 21 minus 3 is 18. But just another way you can think of this to make it go a little bit faster. But we'll go ahead and say this amount is equal to 180. And now we're ready to multiply by 5/9. Now there is a strategy that I'll use, and I'll show my students when multiplying whole numbers to fractions. And that is putting an imaginary 1 underneath the whole number. The reason why is because when we're multiplying whole numbers to fractions, we want to remember that the numerators are being multiplied together and the denominators are being multiplied together. So this helps me keep place of what my denominator is. Now there's two ways we can do this. We could reduce these amounts first, or we can multiply and then reduce afterwards. Either way, it's not going to, one strategy isn't more correct than another. But in this case, I see 180 times 5, and I think, ooh, that's going to be a big amount. Now, if you did take the time to multiply 180 times 5, you're going to get this. So if we multiply our numerators, our top numbers, you'll get 900. Okay. And if you multiply 1 times 9, well, anything times 1 is going to be itself. You're counting it 1 time. So 1 times 9 will just be 9. So this is what I mean by multiplying and then reducing afterwards, because now we have 900 over 9, which is the same thing as 900 divided by 9. So, well, if I was going to think of this as 9, well, covering up my, my numbers here, if I was going to think of this as 9 divided by 9, that's just going to be 1. But then we have an amount here that's 100 times bigger, so I'll need to put those 2 zeros back. And that's just some mental math there, a strategy to do it pretty quickly. But that's me dividing 900 by 9. The answer is 100, just like we predicted. Now, I think a better way to solve these, and it's a good habit to get into, is to reduce first and then afterwards multiply. And that way you can do a little bit more mental math strategies there. And eventually that's where you want to get to. But let me go ahead and do this problem again, but this time I'm going to reduce first. We know the answer is going to be 100 if we were to multiply and then reduce our answer. But what if we reduced first? And here's what that's going to look like. So over here, I'm going to write out the same problem, 180 times 5/9. Well, I can see that I'm going to be dividing by 9 eventually, right? Because I'm just doing 1 times 9. So what I could do is first divide the top and the bottom by 9. And then I'll have an easier time multiplying. And this is what it's going to look like. 9 can actually fit into 180 evenly, no remainder. So what does this mean for us? If I can divide 9 into here, well, let's first divide 9 divided by 9. So if we divide 9 by itself, that's going to be 1. Okay, well, that's going to be a much easier problem to multiply because that's just 1 times 1. As for the top, 180 divided by 9, we can use a mental math strategy for that. I can cover up the 0 and imagine 18 divided by 9, which is 2. So instead of that, I'm going to go ahead and use our new number here, but I have an amount that's 10 times more, right? 18 divided by 9 is 2, but 180 divided by 9 is 10 more, or 10 times more. So it can go in 20 times. I can divide 9 into 180 20 times. Okay, so why do we do that? Because now when we multiply our numerators, we're going to use 20 instead of 180. And we're going to use 1 instead of 9. We're doing the same thing. We're just dividing by 9. We're just doing it first. Now when we multiply 20 times 5, now we're going to have 100. And you can use a mental math strategy with that too. 2 times 5 is 10, and then just add that 0 back. And then we already know 1 times 1 is going to be 1. So same answer. 100 divided by 1, or 100 over 1, is the same thing as 100. And so this is the temperature that at Celsius water will boil. And that's just one real-world example of how we can use an expression to simplify But this expression will actually work for any Fahrenheit. So if the temperature outside is 75 degrees, a nice sunny California day, then you can just enter in that amount here and then do the same steps, subtracting in the parentheses first, and then multiplying out your fraction to get your answer. But let's go ahead and look at some other examples we can use to practice. All right, so we're continuing on with the practice of algebraic expressions. Now I have a problem written out here. Evaluate the expression if c equals 8 and d equals -5. So it's good to get used to the language here when they say evaluate. That just means to make sense of, and usually in this case to simplify. And the expression I'll go ahead and include here. So I'm going to start with a basic kind of a simple example, and then we'll kind of work our way up to the more complex examples. And so once I write the expression here, feel free to pause the video, click pause, and then try it on your own if you'd like, and then we can go over the steps after you made an attempt on your own. So let me start with a basic example here. Let's just do 15 minus, and let's subtract c. Okay, so in this example, c represents 8. So what we're going to do is we're just going to replace c with 8. That's the only amount that we don't know. So once we replace this, then we can go ahead and solve as usual. And again, some quick mental math here. I need to take away 8. So if I first subtract 5, well, 15 minus 5 is 10. And then I have 3 more to subtract. So that would be 7. And that'll be my answer. I'm kind of going from top to bottom to show my work. And that way I can see each step. But your answer here should be 7, right? So that is a more basic example of just plugging in the amount and solving accordingly. Let's see if we can make this a little bit more complex by adding some more algebraic expression type notation here. So let's say we have something like this. We have 3 times the amount of c and d. So if you heard me say this correctly, right? Because you don't see an operation in between the number and the parentheses, we're multiplying here. Sometimes you may see a dot, but usually they will not include the dot when it's right up against the parentheses. So you just need to know that this represents multiplication. So we're going to multiply the amount in the parentheses. Well, you can go ahead and pause the video here if you want to try it on your own, but I'm going to go ahead and use the order of operations to simplify this expression or to evaluate it using these amounts. So the first thing I'm going to do, before I even start simplifying anything in my head, is to just plug in the amounts. So I see 8 for c, so I'm going to replace c with an 8. And I'm going to add d, which is -5. So I'm going to be adding a -5. And so you notice that I kind of have a double parentheses here, right? So I'm going to first pay attention of what this is representing, 8 plus a -5, and then go ahead and worry about multiplying afterwards. So if I'm going to cover up this 3 for now, 8 plus a -5, well, this is the same thing as 8 minus 5. You could think of this as adding a debt, right? If you're adding a debt, that means you're losing money. So if you have $8 and you're adding a debt of -5, you're losing $5. So this is the same thing as $8 minus 5. I find that money helps me to think of these kinds of real-world examples. So you can do 8 minus 5. You can see that that's going to be 3. And that is the amount in the parentheses. That's not our answer because we still need to multiply this by 3, right? So we're basically going to be doing now 3 times this amount, which we said was 3. And well, that's just going to be 9. So that is going to be our answer for that expression. The tricky part there was dealing with some negative amounts. So make sure that you're practicing those negative integers. And I'll make some other videos to help with that as well in the future. So let's move on to a more, even more complicated problem. Maybe we'll do 2 more just to see how you're doing with this. Let's say I have an expression like this. 2c minus 4d. Okay, so again, there's more than one operation here. We're not just subtracting. We're actually multiplying 2 and c, whatever that amount is. And again, you're not usually going to see the dot. And when we start working with algebra, you stop seeing it written this way. Because as you can imagine, x could be a variable. It looks like a variable, and it may cause some confusion. So to reduce that, we'll just write it either with the dot, or we'll just have 2c to show that we're multiplying. Same here. We're doing 4 times d, 4d. So again, before we even start solving, let's plug these in. And remember, we're doing multiplication before we subtract. Order of operations says we need to take care of that first. So I'm just going to replace c with 8. We're going to use the same numbers. Right? And again, I'm keeping this in the parentheses so that way I can not confuse this as 28. A lot of students may, when they're first starting algebra, they may just replace c with 8, and they might see that as a 28, right? And that might cause some confusion as well. So I'm including the parentheses to remember I need to multiply these amounts. Before I do that, let's finish plugging in our variables. This is 4 times d, and we said d was going to be -5. So I'm going to replace d with -5. Again, putting it in the parentheses just to keep track of what my operations are. Well, before I can subtract, I'm going to multiply these out. It doesn't matter which one you do first, just so long as we are clear on what we're going to be subtracting. So here we have 8 times 2. Well, if we have 2 8s, that's going to be 16. And then we're going to subtract whatever this amount here is. So let me just kind of focus on 4 times -5. We know 4 times 5 is 20, but because one of the numbers is negative, we have a positive times a negative, which means that we're going to be subtracting not a positive 20, we're going to be subtracting a -20. So this amount here, let me just cover up this part so it doesn't get confused. This amount is -20 because we have a positive and a negative. But we're going to be subtracting a -20. So the parentheses help me to separate what that amount is here. And that way we don't have 2 dashes here and then having to figure out what that means. Well, we have 16 minus 8 negative. So one way I can think of this, if I need to figure out, okay, which way on the number line am I going to be counting, you could think of this as 16 and the opposite of subtracting 20, right? The opposite of subtracting is adding. And one way that I like to share with my students to imagine this when you have subtracting a negative, in this case, I kind of look at this parentheses, and usually you'll see a parentheses to separate those subtraction signs. It looks like a big plus sign to me. So when I see the opposite of subtraction or the opposite of a negative, I think of a positive or adding. So I'm going to add 16 and 20, but just to keep the original problem here intact, we're going to do the opposite of subtracting, so that's adding. So this is basically the same thing as 16 plus 20. And so that will give us, let's see, well, we add our 1s together, we add our 10s together, and that's our answer, 36. Okay, let's go ahead and do one last problem. This one's going to be the more complex kind of algebraic expression that I'll cover in this video. But let's go ahead and try this out. So in this example, let's say we have 2 times d squared. So we have 2 times d squared, and we're going to add 5d. So we have a lot more steps here in our expression, but again, the first thing we want to take care of is just plugging in that amount. So before I start doing too many steps in my head, let's just plug this in and take it step by step. So I'm going to copy down the coefficient. So that's the first number in front of the variable, so 2, and then times d squared. So I'm going to go ahead and replace d with a -5. using the same amounts. And this is being squared. The amount that we replaced for D, that is the amount that we are squaring. And before we even worry about what that's going to equal, let's plug in the last D here. So that's 5 times a negative 5. So I'm going to use the parentheses to separate and show that we're going to be multiplying. Okay. So of course, before we add and even before we multiply, we're going to use order of operations. And before we can multiply, we need to take care of this exponent here. So there's nothing really in the parentheses to simplify. So the next step in order of operations is the exponent. So before we worry about multiplying, let's do negative 5 squared. And so that's the same thing as negative 5 times itself. So let me draw a little arrow here to show what we're doing. This is negative 5 times negative 5. The exponent tells you how many times to multiply the base here. In this case, that's negative 5. Well, we might know 5 times 5 is 25. And because we have two numbers that are the same sign, so we have a negative times a negative, well, these cancel out. When we have positive times negative, or one of the signs is negative, the answer, the product, will be negative. But in this case, because we have both factors as negative, when we multiply these two negatives together, they will be a positive. So this amount, negative 5 squared, the same thing as negative 5 times itself, is going to be a positive 25. And now we're ready to multiply that by 2. And let me copy everything else over here on this side, that way I can stay organized. So now we're ready to multiply, and again, we don't want to add before we multiply. We're still using order of operations. So let's first multiply 2 times 25. Well, you could think of this as like quarters. So if we have 2 quarters, that's 50 cents. So if we double 25, we get 50. And we can do this at the same step. We can multiply these two together. So now we have a positive 5 times a negative 5. Well, we already did 5 times 5. That's 25. But this time we have a positive times a negative. And so in this case, this is going to be a negative 25 that we're adding. Okay, so now we're finally ready to add, and we have a negative in the picture here. So we have 50 and negative 25. So what you could think of this as, you have $50 and we're going to add a debt of 25. We're going to add a negative, which means we're taking away. So this is actually the same thing. I'll draw a little arrow to show that I'm going to rewrite the problem. This is 50, and if we're adding a debt, that's the same thing as subtracting that amount. So this is 50 minus 25. It's the same thing. So if we subtract 25 from 50, the same way if you had 50 cents and you took away 25 cents, you would have 25 cents. You would have 1 quarter left. But in this case, we're just going to think of it as 25. And that is your answer for this problem. So a few more steps, but again, if you just take the time to plug in the amount and follow your order of operations, then you will be in good shape to get the correct answer for taking your time. So now that we did a couple of examples together, go ahead and pause the video and see if you can evaluate each of these 3 expressions if I give you the amount for those unknowns, those variables. So instead of m, we're going to say that's 2. Instead of n, we're going to say that's 6. And then instead of p, we're going to say that's negative 4. So go ahead and try plugging those in and simplifying those expressions. I'll go ahead and go over those with you to make sure you got the correct answer, but I would recommend you pause the video and attempt these on your own and see how you did. Okay, so let's go ahead and try these together and see if you got the correct answer. I'm going to start from top to bottom. I'm going to start with this expression here, and over here on the side, I'll go ahead and just start plugging them in and show the work down here in this blank space. So I'm going to copy the same exact problem over, but every time I see an m, I'll replace it with 2. So this is the same thing as 3 times 2. Notice how I'm putting the parentheses there so I don't think that's 32. That'd be a very different problem. Then we're going to add 4 times p, but we're going to use negative 4 instead of p. And again, I'm using the parentheses to show we're multiplying. Well, we don't want to add first, we want to multiply first. So let's go ahead and take care of this. So we'll do 3 times 2, which is 6. And then we're going to add 4 times negative 4. So if we just had a regular 4 times 4, if this was positive, then we would say that it's 16. However, we have a negative for one of the factors here. So if we have a negative times a positive, this is going to be a negative 16. So we're taking 6 and we're going to add a negative 16. Okay, so what does that mean? Well, this is the same thing as if we had $6, and again, I'm using the money example. And if we were going to add a debt, that means we are taking away money, right? So this is the same thing as subtracting 16. Well, we're taking away more than we have. So our answer is going to be less than 0. Our answer is going to be a negative. And if you want to visualize what this means, I might draw a number line over here on the side and show you what 6 minus 16 looks like. So let's say we have 0 here in the middle, and I'm not going to count out every single unit, but let's just say 6 is over here on the positive side. And if we're subtracting 16, that means we're moving to the left. We're moving in the negative direction. This is the positive side to the right of 0. To the left of 0 is going to be negative. So if we want to subtract 16, we want to count 16 to the left. Well, if we count 6 to the left, right, 6 minus 6 is 0. So this is us taking away 6. But we have to subtract 16, which is 10 more than 6. So we need to count another 10 to the left. So if subtracting 6 gets us down to 0, we can take away another 10. And of course, 0 minus 10, well, that's going to be minus 10 or negative 10. Well, we just started at 6 and we took away 16 altogether. So this represents us moving 16 to the left. And when we did that, our answer here was negative 10, right? You could think of this as, well, if I have $6 to pay back my debt, then I am at 0, but I still owe 10 more dollars on top of that. So our answer here is going to be negative 10, not a positive. And you're done. So if you got negative 10, you're in good shape. If you got something different, go back in the steps and see if you can catch your mistake there, if possible. Okay, so now let's move on to the second expression. So again, I'm going to go ahead and use this empty space to solve it out. And we have n squared plus 5. So before we even start calculating, let's go ahead and replace n with 6. So we're going to take 6 and we're going to square it. And then we'll add 5 more. Well, order of operations is going to remind us that before we can add, we need to go ahead and take care of the exponents. And in this case, we have 6 squared. This is the same thing as 6 times 6. Well, we can go ahead and take care of that really quick. That's going to be 36. And now we're ready to add 5 more here. So that was just me showing that extra step for those that want to see what 6 squared looks like or what that means. We are just going to go ahead and take care of that first, and now we're ready to get our answer. So if we solve this, well, 4 plus 36, that can get us up to 40, but we have 1 more to go. So it's going to be 1 more than 40, or 41. And that is your answer for the second expression. Again, if you made a mistake somewhere along the line, see if you can follow my steps from top to bottom and catch your error. Okay, the last expression we're going to take care of is here 6p cubed, right? So when you see the exponent here is 3, we're talking about cubes, or we're talking about 3 dimensions in this case. But let's go ahead and work this out on the side and see what this looks like. So I'm going to copy everything else except instead of a p, I'm going to replace it with negative 4. So let's see what this looks like here. We're going to have 6 times negative 4, because we're not going to use p. We're going to use negative 4, and we're going to cube it, which means we're going to raise to the 3rd power. Well, before we can multiply, we're going to first cube negative 4. We're going to multiply negative 4 by itself 3 times. That's what that exponent here reminds us of what we're going to be doing. So over here on the side, let's write out what this means. We have -4 times -4 times -4. Okay, well, those are our three factors here that we're going to multiply. And let's just take this step by step here. So before we mentioned how when we multiply two negative numbers together, that's going to give us a positive amount. So if we have a -4 times a -4, that's going to give us a positive, and then the product there would be 16. That's a positive 16. And we're not done because we have another -4 to multiply. So now we have a positive times a negative. So this is going to mean our answer will be a negative. Anytime we have a positive times a negative, we know our answer will have a negative. Now we just need to do 16 times 4. So on this side, I can go ahead and work that out with you. So we can do 6 times 4 first. That will give us 24. And then I'll carry that 2 over. So 4 times 1 is 4, but then we'll add 2 more. So our answer is going to be a negative 64 because one of the factors was a negative. Okay, so all of that work was just to figure out what -4 cubed was. And let me go ahead and erase this side work, and that way we can make some room. Because let me use a different color here. All of this was one step. So all of this was to figure out what -4 cubed was. And now that we have it, now we're ready to finish the problem because we still need to multiply this whole amount by 6. So to finish the problem, we're going to have 6 times -64. Okay, so we'll just treat this like 64 times 6. And again, we have a positive times a negative. So our answer is going to be a negative again for the same reason. But on the side, let's go ahead and do 64 times 6 and see what our answer will be. Okay, we just did this. So 6 times 4, that's going to be 24. So I'll go ahead and include that here. And now we have 6 times 6, which also looks familiar from this video. So 36 plus 2 more is 38. So our answer here is going to be a negative 384 when it's all said and done. So here is our final answer. Not this, right? That was just for the first part where we were cubing 4. This is going to be our final answer, negative 384. So if you need to go back and check your work here, go ahead and see if you can find your mistakes, but your answer should come out to this.